My name is John Massy. I work for ASRC Federal, and I'm an infrastructure architect for the Chesapeake Bay program. So what we're here to do is take a look at what we've done to implement cloud computing here at the Bay program and how potentially you might be able to utilize some of these resources for your own work. So generically, just kind of take a quick look at what a typical model is and how we execute it, what a high performance cluster is, or an HPC cluster, what are the generic benefits of processing work in the cloud, how we chose AWS as our cloud provider, also how we implemented our HPC architecture, and then take a probably too big a look at the costs of running things in the cloud because it is a little tricky, and then a generic look at what, so now we've kind of implemented our 1.0 cloud infrastructure, what we could do to improve upon that, and then a very brief look at whether or not the cloud is right for you or not, and how to get started in Amazon if that's something you want to get into. So generically, what is a model, right? From my personal end of things, it's nothing more than a computer program, right? You're taking inputs, you're calculating stuff, you're sending out outputs. And I realize from your perspective that might be an oversimplification, but for me, software is software, everything's software. So can you run a model locally or on a single server? You absolutely can, but some of those data sets you might end up waiting a year to get results, and that's not overly useful. So how about HPC, or high performance cluster? When you couple a bunch of servers with what they call a job scheduler, you end up being able to get your results faster and hopefully in a more repeatable way. So let's take a real quick look. We can read the whole definition from the National Institute for Computational Sciences, but generically an HPC cluster is a master node and a bunch of clients. Okay. Effectively what happens is you ask the master node to do a job and it farms out all the work to the clients, gathers those results and gives them back to you from the master node. So you can hit one computer and then ask 20 computers to do the job for you. Okay, and that allows you to compute way more data at once. So looking at what I call the HPC edition of typical model execution. So what do we need to do? We can either take a very large job with lots of inputs and break it into lots of tiny jobs. It works for some models and some executions. Or you can hog the entirety of each one of those compute nodes and run very large jobs in parallel. So overall, you basically can set that up to perform all of your modeling steps through data loading and even down into post-processing if that's what you need to do. It kind of depends on whether or not you know what you want to get out of that data from the start. And so thanks to these lower processing times, by asking multiple machines to do all the work, you can get much faster results. I mean, I think some of the models we run take over a day to run once, and we run them in batches of 8. So, in one day, we're basically getting 8 jobs done as opposed to asking one computer to be busy for 8 days to get the same amount of work done. So, also one of the extra benefits is that because these systems utilize what they call job queue, that it just processes its way down the queue, you can walk away and allow it to do its work, which is a lot better than keeping your machine awake for the next day. So generic benefits of cloud processing. You'll notice the giant asterisk here. The lower cost of ownership is debatable. It can be a misnomer. You can save money. You may not. It really depends on how you utilize cloud resources, what exactly you're doing with them, how long you utilize what, where. Effectively, everything in the cloud is charged in a per hour, per minute, per gigabyte type of way. So if you put giant storage, 100 terabytes or more storage in the wrong place, your budget could be gone this month. You put it in the right place, you can keep adding till the cows come home. It just won't matter because it costs pennies on the dollar compared to storing it anywhere else. But you do need to take the time to break down what you're putting where, why, and how long it's going to be there. Because all of these services, they just want their money, just like everything else, right? So That's the real cost of ownership balance there, basically. The good part is that you do only pay for what you use. So if you're only using 20 gigs of storage, you're only paying for 20 gigs of storage. If you're only using one compute node, you're only paying for one compute node. And a lot of that enters into like dynamic scaling, which is a benefit of the cloud, in that you can dynamically allocate your resources as opposed to having to spend a fortune to get 20, 30 servers to run your work. You can actually use them only when you need them, pay for them only when you need them. Another benefit, and this is one I learned actually making this presentation, you can end up having available data storage that eclipses your entire data center. In a later slide, I noted that Richard is using about 130 terabytes of storage. We don't have that in our entire data server down at the office. We have 80, maybe, for everybody. But in Amazon S3, he can store 128 terabytes of data at about 2.1 cents a gig per month. It does add up, obviously. But
you entertain some questions to go along?
Oh yeah, please,
We're
please.
We're mixing cost a little bit later, and maybe you go into that. But one of the questions when you say very large storage is we're running our models, since they are accumulating, we're writing information out as time. Do you get charged for that as it incrementally builds over your simulation, or do you pay the final value?
Amazon actually provides some very interesting equations on how they work that out, but yes. So if you today write out 50 gigs of data and it's only there for a day, you still get charged for it, but only for that day.
Right.
I don't understand the equation. I wasn't a math major in college, but it's there. You can look it up. And they have a way of figuring out, if you use this much data for this much time, roughly what that bill is going to be.
Okay, well, let me try it again. Suppose the model runs complete in a day, but you write out 5 gigs the first hour, then you're up to 10 gigs the second hour, 30 gigs. How do they, is it per hour per gig?
Yes.
They do it that way. Okay.
Yeah, Amazon recently changed a lot of their price structuring. It used to be on an hour basis. They've actually changed a lot of it to be minute. Okay. I do believe data storage is actually still hourly though. So if you put something up for like 5 minutes, it kind of depends on what Amazon sees when they're reporting data back. You may get lucky. So, and I reference some of these costs later. Okay. It's slightly more relevant, but where was I? Oh, and yeah, one of the benefits of the larger storage types, especially some of the cheaper ones, is that there are multiple ways to access them. I kind of wrote a little key up here, but I figure about half of you can't read it. So Amazon has a service called S3, or what's called the Simple Storage Service. And effectively, it's a Dropbox service. Works very similar. You can mount it as a local drive, but it doesn't work very well. It's not exactly like Dropbox where they keep a copy of their files local. But it's basically a disconnected file service. Speed's not always the best, but it's always there. It's very durable. If anybody has any, on the server side of things, we talk about how many nines of durability or availability something will have. Amazon has, they guarantee like 3 nines, 99.9% availability of bandwidth to get your files, and they guarantee 9 nines of data durability. So they're pretty sure your stuff's never getting deleted unless you delete it. So that's a real benefit because you can store data long-term, cheap, but you have to know where to store it. That is important. And one of the last benefits is that there are different resource types in the cloud. So you can run software as a service, basically saying, I want to run a website, and you don't manage the server, you don't manage the accounts on the server, you just use that piece of software. Infrastructure as a service, that's more along the lines of what I do for my day-to-day job, and that is we give you access to all these resources and you have to build them up yourself, similar to building your own data center. Platform as a service is more like larger scale software. Drawing a blank, but some of the larger ERP-based software is the big software platforms that you could run in your own data center. You can run them also in the cloud, very, very similar. So, all right, so how did we get into Amazon? honestly, I didn't have much say in the choice. I was around when we started using it, but so the Chesapeake Bay program, we're utilizing cloud resources that are purchased by University of Maryland Environmental Science through a grant. Kind of allows us to not live in EPA space, but still have public services available. And then my understanding, and I could have reached out a little bit better and gotten some better data on this, but my understanding of why UMPCs chose Amazon was that at the time they looked at everything that was available, pretty much Google, Microsoft, and Amazon. And at the time, Amazon had the widest array of services, and they are also geographically closer as far as their data center, which does help. I mean, the further your bit's got to travel, the longer it could take. So that was my understanding of how we got there, but I also know that there was part of it was that from a corporate level, when you sign up for these services, you have to sign what they call a master service agreement. University of Maryland already had one with Amazon, so I know that helped make the decision, but it wasn't the only driving case. So what did we do to take our local cloud, our local HPC infrastructure, and move it out to the cloud? So to do this, Amazon was very nice and made a utility called CloudFormation Cluster, or CFN Cluster if you want to Google it. Effectively what this does is this is a command line program that wraps up all the tools that you would need to build an HPC cluster in Amazon and just wraps it up to a config file and a command line experience. All right, so you can say CFN cluster, create, give it a name, and it will literally create that for you and tell you when it's done, and you can log in and use it. Very, very little infrastructure knowledge needed, really. You just kind of sign up for an account and do it. It took me a half hour the first time. Figured double that for anybody that just never really worked at Amazon before. So, you know, in a relatively short amount of time, you can go from no cloud infrastructure to something that you can actually run a model on. So that's what it does. It makes this easily repeatable. So I can create 5, 10, 15 of these clusters if I want in a day, delete them all, and they will all show up and have the exact same software loaded and the exact same setup.
Will they give you a free introductory sort of, you can play with it?
Yeah, yeah.
So they'll give you a couple hours of time?
Way more than a couple hours, actually. Yeah, so the last slide I have on here is actually how to do it.
A year.
Yeah, they will give you a year of...
One core, 20 gigs.
Yeah. Yeah, one core machines, 20 gigs of processing, and the bonus here is that it doesn't actually have to be just one core. The way Amazon works, as I referenced before, is everything's based on hours, or has some time component to it. So when you use an Amazon instance, it's charging for that time. So the way that Amazon actually records that is they say that they round it up. Roughly a month has 750 hours. So basically what you get is very small machines, but you can use any number of small machines in a month up to 750 hours a month for free. And so long as you keep your data storage under 20 gigs, they're happy with it.
So it's just one core though, you can't play with 5 cores or...
Sure you can. You can run CFN cluster and you just don't run it very long.
Okay, I see. So they add up the cores and the hours. And
correct.
Got it.
Correct.
Okay.
So let's see. So, and what you get with CFN cluster is what I was mentioning before about dynamic resources. So when we start up our cluster here, we start it with 0 compute nodes. In our config file, and I can show that a little later if we want, or now if you really want to see it, in the config file for CFN cluster, they allow you to say, what is your minimum number of compute nodes? What is your maximum number of compute nodes? So we put in a 0 and an 8. When the master node starts up, there are no compute nodes. When you submit a job, it creates compute nodes and then runs your job. And then 10 minutes or so after that job finishes, those compute nodes go away again, automatically. So if you have lots of jobs, just add them to the queue. So, and this also, and that's regardless of the operating system that you choose or the job scheduler. Amazon gives you a few options over all of that. So if you've ever used a job scheduler, the one we use is called Slurm. There's also, I don't think this is the name of the application, but the submission name is QSub. I forget the name of the actual software off the top of my head. I mentioned them somewhere here at some point, and I've lost the names in my head. But there's a bunch of them. I looked it up on Wikipedia, and there was like 36 or so listed that were in active development. So there's plenty of different ways to run your jobs. Also, so you're getting a base Linux image, right? Very, very basic. It doesn't have all the stuff configured that you would need on your day-to-day, especially for things like Fortran, since Fortran isn't necessarily the first thing that you expect to find on any machine these days, just given its age. I'm not judging. But things like Java have basically taken over.
Isn't that coffee?
Coffee works.
Java, right?
Java?
Do you have any? I'll take some. But so what you end up having to do is, well, not having to do, but what you can do is you can create basically a very simple bash script that, for Red Hat system runs yum install all the different software packages you need. So when any compute instance is started up, or whenever you create a new master node, all that stuff is installed by the time you can log into it, or by the time that a job can be submitted. In our environment, we also changed a single user system into a multi-user system, added extra shares for data storage, all kinds of customization you do. But basically, if you can script it, you can do it. Sometimes, if you've never done administrative scripting on Linux, it might take a little bit of time to figure out, but it's not so bad. And basically, at the end of the day, this allowed us to basically pick up our current HPC architecture and plop it back down in the cloud. Really, the only thing we had to do was move all the data when it was all said and done. So that took a while, but once it was done, it was done.
So do you usually store the executables long term, and then you just load them into the instances as you start up? Is that how you do it?
Yeah, so Amazon has a way to snapshot disks so that once everything was loaded, you can say, I want to make basically a backup of this disk based on a snapshot. We actually had to do this a couple months ago, where we had a problem with our main server, and the easiest way to fix it was to rebuild. Actually, the only way to fix it was to rebuild. It was my own fault. The version of CFN cluster was just too old. I rebuilt it in about 3 hours. And that was long. I kind of took my time.
And then you just take a snapshot of that, and then you can install that?
Yeah, and basically I pointed to the snapshot, the backup of the last model, and it just pulled it all in and created a new disk out of it, so everything was basically like we never left. So, and let me take a really quick look at these, because I thought these were a little big for a slide.